Right, we're on the hour, so we're going to formally kick off. Welcome everyone to this first session, this first webinar for 2025. I'm Nicola Elliott-Wong, H3D Foundation Program Coordinator, and it's my great honor to host these sessions. Today we're in excellent hands, everybody, and I know we've been promoting this quite widely amongst our network, because so often we're asked about presentation skills, communication skills. How do we get our message across in the most effective and thoughtful and efficient way possible? And so we reached out to John because he's known in both careers, his two careers, as being a fantastic presenter, and he's got lots of experience and advice, tips and tricks, skills and strategies to share with our network. So I'm going to briefly introduce him. He doesn't really need an introduction to most of you, but here goes anyway. Dr. John Woodland is a research officer at UCT's H3D, as we all know, the first integrated drug discovery center in Africa, and a fellow at UCT's IDM. Currently under the mentorship of Professor Kelly Chibale, John's research interests lie in the development of molecular treatments and tools to tackle the scourge of infectious disease, with particular emphasis on the applications of medicinal chemistry, chemical biology, and machine learning to the field of malaria. John is also passionate about promoting science and improving scientific literacy in South Africa. He is also active as a musician in Cape Town and plays the organ, directs his own choral group, and presents weekly broadcasts on a local classical music radio station. John, we're absolutely honored to have you. Thank you so much for agreeing to do this. I'm going to hand over straight away. Oh, but first a word just to say we've got our presentation will be about half an hour to 40 minutes or so. And then, of course, there'll be time for a Q&A. So please note down your questions. I think the chat is active. You're welcome to pop them in there, and we'll have time when you'll be able to use your mics later on in the session. Over to you, John, and thanks again.
Fantastic, Nicola. Thanks so much for the very kind introduction, and thanks everyone for being here as part of this kick-off webinar for the H3D Foundation for this year, because communication underpins everything we do, not only as scientists, but as people, as humans. I think it's quite appropriate to be starting off with this as a kind of broad, overarching, perhaps even theme for the year. So thank you for being part of this, and I hope you will find some aspects of it useful, and you'll be able to incorporate perhaps some of these suggestions and thoughts in your own work. But perhaps just a little bit of background to myself, although Nicola has given me a very kind introduction. But if you're interested just in sort of the shape my journey took, just to give a little more context to why I find these questions and ways we communicate and present with one another interesting and important. I've been very lucky to be at UCT my entire academic career, starting off with double majors in chemistry and biochemistry before realizing it was the world of molecules that really enticed and beguiled me. So I went all the way to the PhD, which was broad in scope, and so that allowed me to do two different postdocs, first in biochemistry and then in medicinal chemistry. And it was really also in these two different postdocs that I realized, you know, even though the worlds of biochemistry and medicinal chemistry are so gulf, this chasm of communication between the two. Chemists like talking about small molecules, biochemists like talking about big molecules. So how can we effectively kind of bridge that divide in a way? And then more recently, my focus was on chemical biology at H3D, where I'm now a research officer, where I now supervise students and do some teaching. So that has opened up kind of further avenues for optimizing communication and presentation. Put another way, because chemists often like reaction schemes, this is a reaction that's taken place against entropy over many millions of minutes, mostly room temperature and pressure, with a very important catalyst involved, caffeine there. So over the years, I've been involved with various different communication fora. As a postgraduate, getting quite excited by platforms like FameLab, the Falling Walls Innovation Competition, really starting to explore ways in which we can effectively communicate not only with the public, but with funders, with our scientist colleagues, presentations are one way of doing this, but writing is also an important avenue in which we as scientists express ourselves. And I've had the opportunity over the years to write for newspapers such as the Mail and Guardian, which is a South African newspaper, but also Chemistry World, which is a magazine primarily aimed at chemists. So when one is talking to essentially one's parents or non-scientific friends through the newspaper, or writing for a magazine that focuses on scientists, of course, one's approach is going to be a little bit different. Involvement in all of these kind of platforms and fora really made me very aware of the science news cycle. You may have seen this meme before. So forgive me for being a little bit indulgent. It's obviously an exaggeration, but it's a reminder to us of how easily what we do can be misinterpreted, not always in a helpful way. So, for example, you do an experiment, you find A is correlated with B, not in a statistically significant way, but this is interpreted by, let's say, the university PR office as being quite an exciting finding, and so they put it up there, or out there these days. Journalists then pick that up, and suddenly correlation becomes causation. And they talk about how A is now causing B. This goes wild on social media and the internet, eventually sort of filtering down back to society, where maybe someone like your grandmother, then finds this very strange report that now bears very little resemblance to your original research in the news, that leads to some kind of action on her part, which may in this case be misinformed. So you can see it's very easy for what we maybe regard as, very clear scientific reporting and finding, under such and such conditions and assumptions, for those who maybe don't have the same training or background we have, to kind of misinterpret those kinds of findings. So this is kind of a worst case scenario, but in recent times, public health emergencies, for example, we need to think very carefully about how we communicate. And so maybe over the last few years, you, like me, have been similarly bewildered and frustrated by kind of the difficulties of doing science, but also doing science in Africa. And these are all headlines or memes that have appeared over the last few weeks that are really enormous cause for concern. USAID, the NIH have been targeted by the recent new US administration. And of course, these are not acute events. They're going to have many, long kind of term ramifications that, regrettably, as is often the case when the global north makes these big kinds of decisions that are disproportionately going to affect the global south and the poorest people on our continent, for example. So in a case like this, who is to blame and what can we do about it? And unfortunately, I think we do, to some extent, have ourselves as scientists to blame. It's quite interesting to read the writings of, he was a British philosopher and writer, C.P. Snow. Already, over half a century ago, a seminal speech he gave called The Two Cultures, in which he warned us that, in a way, society is becoming super specialized. The scientists are all kind of doing their own thing on one side. Everyone else, especially kind of the arts, so drawing this sort of dichotomy or distinction between the sciences and the arts, are doing their own thing. And the lack of communication between the two is really hindering a lot of problem solving, which these days, for big problems of our time, whether it's clean energy, global health, illnesses of the mind, are going to require interdisciplinary, transdisciplinary teamwork and solutions. So in a way, this kind of false dichotomy of science and everyone else has really become bad over the last few decades. In fact, and I have to include a little bit of poetry here, one of my favorite English romantic poets, John Keats, also wrote, sort of 150 years ago already, philosophy, and by this he means more natural philosophy, which is what science used to be known as before science, that term, was coined in sort of the mid-19th century. Philosophy will clip an angel's wings, conquer all mysteries by rule and line, empty the haunted air and gnomed mine, unweave a rainbow. So really painting science in a very bad light about how we, want to dissect the natural world without appreciating its beauty. And I hope you'll agree with me, that's a very unfair, one-sided, and in some ways unhelpful kind of evaluation of science. A really great science communicator in the past century was Richard Feynman. You've probably heard of him. He was a physicist, won the Nobel Prize in physics for quantum electrodynamics. And he famously responded to Keats, albeit a century later. And if you'll forgive me for reading this, because it is beautifully poetic, although if you think it is written by a scientist, poets say science takes away from the beauty of the stars, mere globs of gas atoms. But I too can see the stars on a desert night and feel them. But do I see less or more? The vastness of the heavens stretches my imagination. Stuck on this carousel, my little eye can catch 1 million-year-old light. It's a vast pattern of which I am part. What is the pattern or the meaning or the why? It does not do harm to the mystery to know a little about it, for far more marvelous is the truth than any artists of the past imagined it. Why do the poets of the present not speak of it? What men are poets who can speak of Jupiter, the god, as if he were a man, but as if he is an immense spinning sphere of methane and ammonia, as in the planet, must be silent. And I think this is a great reminder to us, in the early 21st century, when we live in a scientific age, our lives are governed by science. The fact that we're having this webinar, the medicines we take, the foods we eat, everything is underpinned by science and the results of those scientific discoveries. Why, in a way, do our poets and artists and us not celebrate more our accomplishments? I admire the writer Bill Bryson, who also put it in a very good way. And once more, who do we blame? Of course, we're not trying to blame. We're just trying to get to the bottom of what the problem is here. But he famously said some years ago, there's a real problem with the education system. I think all students should come away with at least a basic understanding of science, what it does for us, and an appreciation of how important science is to telling us who we are, where we're going, and how we solve problems in the world, because we know that science and the scientific method is the best way we have of generating knowledge and of solving problems in the world, especially these difficult problems. And so when we see from our leaders and political elite this mistrust, this distrust of science, and yet they're only too happy to benefit from science's advances, it's kind of a frustrating situation. But again, I think we as scientists really need to take ownership of this chasm, this dissonance, and we have an obligation to communicate our science effectively, to advocate for science, to only promote information that comes from a reliable, credible source, and so on. So these days, you won't attend a webinar or presentation without some reference to AI and ChatGPT. So I asked ChatGPT to draw for me the science communication ecosystem. All these role players, scientists, universities, journalists, the public, policymakers, how do they all fit together? And I mean, this is quite nice. Sure, it's the ecosystem. I guess that's a symbolic representation of the tree of knowledge. I'm not quite sure how I feel about the one person sitting at the top as if they hold the truth or the right to knowledge, because let's not forget, science is not perfect. Science is not, science is fallible, but we have mechanisms in place like peer review that are going to help us correct if mistakes are made. So I didn't quite like this. I asked it to redraw from the same prompt, and it came up with quite a nice, less environmental kind of network diagram of all these role players in science communication and the kinds of engagements that they're having and how those feedbacks are all connected. I didn't really like this either, so I thought I'd draw my own one. So please excuse the PowerPoint graphics in this next slide. But I think it is helpful as we think about effective communication, especially as scientists, because I think most of us in this audience are practicing scientists. We do science, so perhaps these scientists represent you, and we mainly communicate to one another through presentations, reports, scientific papers, and manuscripts that form part of the scientific literature. It's kind of the official way of communicating science. Maybe if you're in this presentation, you're more of a supervisor or PI, maybe more of a kind of a manager. That could be you. And you would expect to hear from your scientist underlings or minions, don't mean such a pejorative word, from presentations or reports, but those may be structured differently from the kinds of presentations or reports that working scientists are going to write for each other. On the other hand, you may also be a student. If you're an undergraduate student, perhaps your way of interacting with scientists is through lectures, which again will be a whole different way of expressing and communicating scientific concepts compared to, let's say, you're a postgraduate student, maybe you're a master's or PhD student, and you will also communicate with your supervisor, more senior scientists via reports or presentations. But perhaps in those reports or presentations, you're going to explain or show maybe what didn't work, how you've optimized procedures, things that might not make it into the publicly available scientific literature. So even within our kind of internal scientific community, there's so many different ways of presenting, packaging, reporting information. So when we think beyond just the scientific community, let's say with donors, funders, government, politicians who might put out funding calls, we will then submit proposals to them. When one frames potential work in, say, a proposal, you're going to do that very differently once again from any of these other forms of communication. I mentioned it a little bit before. And then when you have exciting things to report, this is a little bit of an old-fashioned way of thinking about it. You may put together a press release, or your institution puts together a press release to share with journalists, who will then share those data, that information in some way. And this is where perhaps misconceptions can start to come in if there's kind of a disconnect or a lack of understanding, or just in some respects, poor communication along any of these channels. And so the public, let's not forget, you might be a scientist in this room, but you are the public as well. You may be an expert in your niche area, but not an expert in all fields, perhaps, although you do bring to it a very transferable skill set, critical thinking, attention to detail, problem solving, and so on, that perhaps the lay public in general don't have. Of course, scientists, institutions can communicate with the public directly these days through social media and websites. And we'll spend quite a bit of time a little bit later talking about how you as a scientist can engage and ought to, should have an obligation to engage with the public through your writing, speaking, social media, and so on. And then just as a little cherry on top, you know, the public is not a homogeneous mass of people. There are different kinds of people at different ages, at different socioeconomic groups with different concerns and priorities, one of which is youngsters. When we talk about scientific outreach and inspiring the next generation, how you convey your science to, let's say, children is going to be very, very different from how you convey science to anyone else in this communication ecosystem. So let's do a little bit of a dive, but first, and this is perhaps the key takeaway message from this, the golden rule of science communication and presentations. You all know it, but it's useful to spell it out. Know thy name and thy audience. In other words, what are you trying to communicate and who are you trying to get it across to? And depending on those two things, you're going to package it, think about it, present it in very, very different ways. So whenever you have a reporting assignment, whether it's a presentation, a public talk, a grant proposal, going onto X or Blue Sky to tweet something or post something, think about who is going to be receiving this on the other side. And it's hard to put ourselves in other people's shoes, but it helps at least to start framing in a better way to make sure that that communication is effective. So please keep this in mind as we go through the next few slides. But I really want to focus just for the next 5 minutes or so on the kind of the internal scientific ecosystem. How do we communicate with each other? That could be to your project team, your student, your supervisor, at whichever career stage you're at. So I apologize, I'm breaking a rule here by putting a hell of a lot of text on one slide, but fortunately this is being recorded, it's shared afterwards, so you can always look back at this. This seems very basic and very obvious, but it makes such a difference, and I'll get to that in a moment, when you're presenting written reports, dissertations, theses, and a quick acknowledgement to my close colleague, Dr. Catherine Wicht, with whom I kind of came up with this list. We work closely together. And so we realized over time, we keep on writing the same kinds of things as we're reviewing documents. Let's put them all together in one document. Although the American Chemical Society has done this already, and even though they're a chemical society, of course, they publish a lot of biological work. And so what they've published in this book, available online, of course, please look for it, is invaluable for anyone in the scientific enterprise. But really thinking about being consistent throughout with your formatting, your spelling, defining abbreviations, ensuring you present data in the right way, including that space between the number and the unit, because that is the way we've agreed as the scientific community with the SI system and all of that to present data. Thinking about how we write, we shouldn't personify things like molecules and spectra and that. We should say, the spectrum of the molecule. It makes it a little more, on the one hand, sort of long-winded, but it also avoids potential ambiguities and challenges later on. We need to prioritize kind of clarity, especially also bearing in mind not everyone who's reading what we're producing is necessarily a first language speaker. Being careful when you use technical terms, checking that your claims are appropriately referenced and so on. Things but this is why this is important. So firstly, writing is a really important way to organize your thoughts. If you're struggling to write or get something down on paper, it may suggest that maybe you're not as comfortable or as sort of thoroughly understanding of the concept that you're trying to convey. So in fact, that's a great way also of trying to understand something better is really grapple with it through words. But also, all of these kinds of points, that attention to detail gives credibility to your work, right? If you read a document, a report, a paper that is, beautifully presented with great attention to detail, suddenly it gives a lot more gravitas to that work. You're much more likely to kind of believe it. It gives that work, again, the credibility, whereas if something is slapdash put together, there are mistakes, then you wonder, gosh, well, if there are mistakes here, what other mistakes were made as the experiments were being done or along the line? And that all feeds into making it as easy for the reader as possible. A big theme of communication is ease with which this information is conveyed. If you're writing well, clearly, consistently, that makes it so much easier for the reader. They don't have to worry, oh, but now why have they changed this abbreviation? Or didn't they say something different earlier? And as soon as you start to integrate those kinds of roadblocks or obstacles into your writing, you're already kind of losing your audience in some way and losing kind of the main emphasis of what you're trying to get and the effectiveness with which you're conveying your message. And especially with writing, a top tip I've found is, if in doubt, read it aloud. If it sounds cumbersome, if it sounds confusing, when you read it, chances are when the reader is reading it, probably in their mind's ear, they're also going to be stumbling or a little bit confused. So really just 4 top tips here for when you're doing scientific writing. Presentations. We've all seen schemes like this. If you're a medicinal chemist, what's good or bad about this? What do you think of the way it's presented, the size, the fonts, the bond angles? I mean, there are no subscripts in these reaction conditions, for example. Okay, I kind of made this up, so forgive me for not including temperature and solvent and things like that. But the slide is big. You're wasting space by squeezing it into a little corner. You're drawing attention away from, if this is the main scientific message you're trying to convey. Bond angles are awry. There are no yields. Why not give codes for the compound so that the person who's, let's say, questioning you in a presentation doesn't have to go, okay, second compound from the right. They can just say, compound 3. So really think carefully about how, as a chemist, you present your data, maybe incorporate a little bit of color, really try to take a step back and think, if I've never seen this before, how can I make it as easy as possible to see it for the very first time? Again, not saying this is perfect, but I hope you'll agree it's an improvement on what was presented at first. And of course, the same goes for biological data or physical data. What protein, what the concentration of what compound and what units, where are the error bars, all of these kinds of things. Every measurement has an uncertainty, as we know. So perhaps this is a better way of presenting that figure. Okay, a little bit of color helps. Let's put the IC50 on the graph rather than maybe tucking it away somewhere else. So I hope you'll agree. Once again, maybe it's not perfect and you might have better ways of doing it, but this is at least some improvement over that communication. So once again, top tips for presentation, specifically over writing. When you see slides that are good and clear, examine them, take notes from them, learn from them, take a step back. It's always difficult to detach yourself from your work. You think, oh, it's so obvious, of course, everyone else would think this too. No, it's very different. When you've done the experiment yourself, you have very privileged, intimate knowledge that is not immediately obvious, even to someone skilled in that art in your field as well. So Steven Pinker talks a lot about this. He's written a lot about cognitive psychology and how our brains process information, what he calls the curse of knowledge. Once you know something, it's really difficult to imagine what it's like not to know it. And that's why we find, top researchers may not be the best teachers because they're so good at what they do. They're so immersed in that worldview, that way of thinking about things, that now to convey it to someone who doesn't have that mental framework or scaffolding in place, it can go right over their heads. There can be a massive disconnect there. So something to think about, taking a step back, doing the thought experiment, but what if I didn't know any of this? Is it easy enough for someone to pick up on seeing this for the first time? Much harder than it appears, or than one might think. And again, you want to make it as easy for the viewer as possible. And really, this attention to detail gives your work credibility. If you're presenting your data, again, not to say we want to cover up bad data, but if you're presenting your findings in an attractive, careful, thoughtful way, then people are much more likely to be convinced and to come to the same conclusions that you yourself have come to. Just to spend a little bit of time thinking about this very privileged niche of scientific communication, which are publications or manuscripts. And of course, as scientists, we all know why these are important. We want to contribute to a common body of knowledge. That's how science evolves. That's how humankind can progress, can learn from and benefit from the experiments we've done. It's an important record of why we did things and what we found and how we reached our conclusions. And of course, this is a mechanism for others to evaluate our work, what we call peer review, which is important. It allows science to self-correct over time. And once again, there's going to be a diverse audience here. Your students might read them, your potential employers or supervisors may read them, policymakers may read them. And so once again, it's incumbent on us as scientists to think carefully, who am I writing this for? And what is the message I'm trying to get across? Knowing my audience and my aim. And this is probably, you'll see this again, but one's got to remember that science isn't finished until it's communicated. If the data are sitting in your lab book or on your hard drive, that's not very, very helpful. I understand if it's tricky, if you're doing sort of proprietary work, but there must be ways ultimately to make sure that work can translate, very important word in science these days, translate from the bench to the bedside, or whatever the case or context of your work is. I know many of us in this room are very interested in global health, especially. And so just for a moment, it is useful just to remind ourselves what we're trying to do with papers. I mean, on the one hand, inform, but we're not trying to impress. We're trying to be clear, accurate, concise, but we are also trying to convince the reader that what we've done is important, is valid, is relevant. And these are the kinds of aspects we're trying to get across in our paper or a research article or book chapter. Why was the experiment conducted? What are the questions that are being addressed, and so on. But of course, many of you, especially if you've been in science a little bit longer, know this well. This is second nature. And then just to mention that Kelly Chibale and I did write a manuscript last year in ACS Medicinal Chemistry Letters, an editorial rather, thinking about what tips can we give those who submit manuscripts to this journal to really give them maximum chance of getting their manuscripts accepted. And once again, these are transferable, not just medicinal chemistry, it applies to everything. You know, really thinking about carefully what is the most appropriate journal, the most appropriate manuscript type for your publication. Is it a communication? Is it a full article? Really looking to the journal's author guidelines to making sure that you are making it as easy as possible for the reader, for the editorial team to decide whether or not to accept or send your manuscript out for peer review, and so on, making sure you scrupulously report all the experimental details, sufficient characterization data, and so on and so forth. But again, notice how the nuance here, the framing is a little bit different from a presentation or from a report. You might be writing a thesis or a dissertation. Let's not forget the poetic and the humor. Titles are important as well. So a little commercial break, just some memes, fantastic yeasts and where to find them. If I worked in fungal work, I wish I'd come up with that title. Medical marijuana, can't we all just get a bong? MIR on the wall, who's the most malignant medulloblastoma MIR of them all? And I'll leave you to read the last one. But we are people at the end of the day, as well as scientists, and humor in the right context goes far. So you've seen this a little bit earlier. Here's our ecosystem. We spent quite a lot of time talking about types of communication formats within our internal scientific kind of enterprise, but now looking outwards towards the public, because the big kind of challenge I want to give you at the end of this presentation is that we as scientists really have an obligation to actively engage with our non-scientific communities and the public. So how do we go about that? What do we need to think about when framing this kind of communication? So science communication, I guess, is a little different from scientific communication, subtle, which we've been talking about up till now, but now we're thinking about science and broader society. Probably non-experts. We're raising public awareness. Maybe we want to excite people about science, what we call outreach. Maybe we have a very particular agenda in mind to inform some aspect of public policy. And this is really important. I mean, there's a lot of people weighing in on the value of AI in science at the moment. It's a bad thing. It's dangerous. It's scary. But we've seen some very exciting implementations in our day-to-day life as, let's say, drug discovery scientists at H3D. And let's tell the good stories as well. Of course, in the context of COVID, we all know how information, it's hard to know, even for us as scientists. What can we trust? Who can we trust? Making up our own minds is difficult. Can you imagine how folks feel who don't have the kind of scientific training we have? So just few quick reasons on why good scientific communication is important. Of course, educating the public in a non-patronizing way so they can make informed, rational decisions. We, of course, want to make science transparent and really, build the links, positive links between science and government and society. And yeah, ultimately, so we can make evidence-based, public policy so everyone can benefit. Physics has Neil deGrasse Tyson, biology has David Attenborough. If you'll excuse me, because I did mention earlier, my sole scientific home is chemistry. What do people think and feel about chemistry? And I'm always intrigued by this survey that the Royal Society of Chemistry ran some years ago, that people mainly feel neutral about chemistry. I guess it would be worse if they felt scared or confused or bored about it. But it just shows that we as scientists, and particularly in a discipline like chemistry, where we don't have these kind of sexy role models like deGrasse Tyson or Attenborough, we do have an obligation to communicate and engage with the public. So we live in a scientific age, but I think you'll agree there is, especially we're seeing from the US at the moment, this sort of distrust, this mistrust of science, which kind of turns into a lack of respect that works both ways, because then we as scientists think, oh, what do these people know? They don't know anything. They're making these stupid decisions that are going to have massive ramifications down the road. But what are we actively doing to address that? And of course, here in South Africa and on our continent, we have problems of our own. A News 24 article from some years ago that something we really think as absolute basic scientific literacy is not as common as we'd like to think. Of course, as drug discovery scientists in the global health space, we do have really exciting news to share, good stories to tell, but these are difficult and emotive issues. And so we need to think carefully about how we present this kind of information. And one can come up with graphics and taglines like half the world's at risk from malaria. In some ways, I find these kinds of things distasteful, but maybe in a way they do kind of draw an emotional urgency to the work we're doing as well, at least as a segue into the really positive news, to tell the good news of what we're doing at H3D, that we are actually making progress. We can do drug discovery in a meaningful way on this continent, whereas up till now, it's predominantly happened, in the global north. But again, it's complex and emotive. How do we communicate and convey this effectively? Nicola kindly mentioned my other life as a musician, so maybe using an analogy like drug discovery as an orchestra, where perhaps we have someone like the medicinal chemist as a conductor, bringing together all the other players, the musicians, the scientists within that orchestra to harmoniously create a composition that's going to generate solutions to unmet medical needs, for example. If you do more biology-based work, images like this speak for itself. Let's really use this as a way to capture the public's imagination, get people excited and inspired about what we do. This is a T cell, by the way. And it's not just about giving, it's also about receiving. SciComm is valuable. It helps you to refine your writing and presentation skills. It can reveal new perspectives that maybe you were too much in the weeds to realize, can facilitate valuable new connections, and importantly, bridging the gap between science and society, motivating, inspiring, educating, again, in a non-pejorative way, a non-patronizing way. The public. And we do have some good role models. Angela Merkel did her PhD in quantum chemistry before she went into politics. There's Natalie Portman at the bottom. She's written a paper, or was part of a paper in the Journal of Chemical Education when she was still at high school. And the lady on the far right is Margaret Thatcher, a very important politician in 20th century British politics. And she's trained as a chemist. She helped to develop soft serve ice cream before going into politics. So maybe we need more scientists who are going into politics. Just a few tips. Again, you've heard me say this, knowing your name, your aim, your audience, practice, practice, practice. We all know how it feels to go up, stand up in front of a room. Maybe we haven't put in quite as much preparation as we'd hoped, or we're getting tongue-tied around those complex scientific words. Opening and closing impact are really important. Often that's all folks remember, right? We've all heard of the presentation kind of sandwich in a way. Strong start, strong end, and what's in the middle kind of gets forgotten. Learning from the best. You can check out all your heroes on YouTube these days, see how they deliver brilliant talks, write excellent papers, and learn from them. Body language is important. Sadly, this is a hybrid, or rather a webinar. It's not a hybrid event, so body language, only 2 dimensions. And enthusiasm is really key as well. If you want to draw someone in, if you're bored about what you're talking about, it's going to fall very flat. And if you are keen to whet your, what do we say? Not quite sure where that analogy goes, but to get involved with scientific communication, free blogs, microblogging, platforms like X, like Blue Sky, Instagram, even, writing for your department. You can offer to write, notes, press releases, ways to get undergraduate students excited in the research that's going on if you're in an academic environment. In South Africa, we have some great national agencies or professional societies, things like, if I get this acronym right, the Society for the the South African Agency for Science and Technology Advancement. They do a lot of work in running communication competitions, getting people excited and inspired about science. And there's so many online communities as well. There's a very powerful one on Facebook called Science Communication Africa that really brings together people who are passionate about getting involved with science communication across our continent, which is very different from SciComm elsewhere in the world. We have our own challenges. And importantly, as advocates for science every day, in every conversation you have, in every interaction, think, am I being rational? Am I representing the science correctly or in the best possible way? And just as a little cherry on top, thinking of the next generation at UCT over the last few years, we've put together some quite exciting public demonstrations to get kids excited and inspired. But once again, a whole different way of thinking about what we do and hopefully igniting a kind of childlike curiosity and flame within us. So I hope this has been helpful and in some ways kind of inspiring, or at least just opening your mind to start thinking about the nuances here. It's very complex what we're doing, but it's also an enormous privilege, but an obligation as well. There's my email address. Please do get in touch. I hope this has helped to kind of unpack what science and scientific communication are to our different constituencies, why it's important, how we can maybe do it better, how it can benefit you, the skills you learn that are transferable to other disciplines, how to get involved. We had a fantastic H3D Foundation webinar last year by Renata Lazarova, and she also used this important quotation here. There's the YouTube link if you'd like to watch it again. But she went into a little more detail about when you give those presentations, what are some of the really valuable things to think about and remember. So 3 last closing messages to kind of synthesize everything we've said and cap it off. So as scientists living in a scientific age, we have an obligation, a duty to bridge the gap, this ever-widening chasm between the two cultures of science and non-scientific society, as we build, on the one hand, a rational, but on the other also an empathetic and caring community from which everyone can benefit. And so we need to think very carefully about how we communicate. And I think we all need to commit to developing our communication skills. Like science, it's an iterative process that gets better the more we do. And as time goes on, got to be a little bit self-critical now and then, but it will make us better scientists and help our work to ripple outwards. Really leveraging our scientific skills and expertise to speak out. So really being proactive and promoting only credible information from reliable sources. Now more than ever, we need the scientists to speak up, to get engaged, not only within our own communities, but within the broader ecosystem and society as well. So thanks very much for your attention. Very happy to take any questions.
John, thank you so much. That was really fantastic. And I'm seeing, yeah, I think I've enabled your microphones. Please raise your hand if you have a question. And it occurs to me as I am listening to you, you know, I've worked with a lot of people in a lot of different sectors, and often we get into a particular job or role and we think, I know what this is going to be about, right? I know the skills that I need. I want to be in the lab for many years, you know what I mean? That's what I want to do. And then you get there and you realize, hang on, there are all these other skills that we need to work on. But it's also fundraising, you know, well, most of us are self-funded. So you've got to think about all of this stuff. How do you build? Universities aren't these places that you retreat to now. You actually really have to be interacting with the world out there. And for a lot of scientists, perhaps who may be a bit introverted, that can be terrifying, right?
Absolutely.
And yeah, so not to, speak to the cliche there, but I think often we think, oh my gosh, what am I to do? And then you realize, okay, let's take this one skill at a time, right?
Absolutely.
Okay, Chris, yeah, do you want to comment on that? And then we'll hand over to
yeah,
Chris.
I mean, just to say, brilliant reflection. And it is a challenge, but it's also an enormous privilege. And that's one of the reasons why, okay, you do catch me on a good day today. Maybe not optimistic and so enthusiastic every day of the week, but it is cool to be able to get out of bed in the morning. No 2 days are the same, because maybe today I'm going to be in the lab all day. Tomorrow I'm going to be writing a report or putting together a presentation, and I have the opportunity to develop all these other skills to become a more holistic person that can ripple outwards into other aspects of our lives. I think everyone should have a scientific training, at least for a little while, not only because of the cognitive skills we learn, but all these other valuable skills too. And then if we were to go and specialize after that, okay, now into engineering or politics or some kind of performing arts, I don't know, maybe that's too much to ask in a scientific age. But on the other hand, when our lives are so dependent on science, perhaps everyone ought to have at least that foundation in how our sort of society is built. Over to the others.
Okay, Crystal, I think if you can unmute yourself, go ahead with your question.
Okay, thank you very much. I'm not very sure if I missed anything on poster presentations. I know it can be very challenging sometimes trying to summarize a lot of ideas on a poster. So can you give a few tips on how to make a poster more communicative and catchy?
Brilliant, Crystal, thank you. And next time I give this presentation, I will definitely include a slide on poster presentations. That was quite an egregious omission. Apologies. So you didn't miss anything.
Okay.
I guess, I mean, once again, the same rules apply, right? Thinking very carefully about who your audience is and what is the aim of your poster. Are you trying to summarize your entire MSc or entire PhD? Or are you maybe it's better just to present one slice of your work and to do that in a little more detail? It's probably better in a poster not to overwhelm the viewer with too much information, because you might only have their attention for a minute or two. And so really thinking carefully about what are the main messages I'm getting across, if you'll excuse the expression, what are my kind of sexiest take-homes, and then sort of working backwards from there. You know, a poster presentation is kind of like an elevator pitch, when they say you get into an elevator with someone, you've got 30 seconds to sell your idea, and that's it. Something I found useful on a practical level when doing poster presentations is either having printouts of the poster, let's say just on A4, that people can take away with them. If you don't have time to explain everything, you say, well, if you're interested, take this away. Or having a QR code on your poster that then, you know, someone can immediately scan, link to a PDF online of your poster. So again, they can easily take something away from the poster so that the interaction is more long-lived. It's not just the few minutes you have. But I think all the usual kind of advice for presentations really apply to posters as well. Keep it as graphic as possible, whether it's reaction schemes or mechanistic reactions or graphs or docking poses. Focus on just a few of those. And if you can talk more than, you know, letting the text on the poster read for itself, you know, that's first prize. If you can guide the listener or the person through the images, although it's tricky because sometimes you might not always be at your poster, so you need to make sure your poster can also tell your story in your absence. Things to think about. I hope that's helpful.
Yeah, thank you very much.
And maybe, Crystal, if I can suggest, and once again, use the internet, use Google, use ChatGPT. Even if you type in poster, you know, tips for scientific presenters, other people have asked that question, have given much better answers than mine. Let's learn from others who've done it before, so we're not reinventing the wheel. You're not cheating in any way. You're just being like a good scientist. You're doing your homework, doing your literature review before you embark on a task.
All right, thank you.
To elaborate on that, I mean, the industry that I came from before, which was the theatre industry, you know, before we'd show our performance to the public, we'd have what we call showings. And we'd very consciously select different types, you know, it's a controlled group basically of people that you want to see this show and give you feedback on. And I think do the same thing with your poster. So think, who's going to be walking past here? All the people who are going to be walking past here who I want to communicate with, you know, whether it's going to be a school tour, get your nephew or niece in and go, what do you think about this? And listen to what they have to say, right? It's not just your supervisor or your people who are in the know who are going to validate that, what you've got to offer. It's actually everyone. So get them in, get them to read it, see what they have to say, see what they offer you, and then work on that. So I think, Crystal, also just thinking about the time that takes and factoring that in, that's an important part of your process, is to give yourself the time to get that feedback if possible. There's a larger question as well. How can we improve the clinical research in Africa, which still seems to be lagging compared to the US and Europe? Off you go, John.
Great question. Let's schedule next week's webinar on this question. I mean, that's a great, I mean, and there's so many aspects of clinical research, right? There are the trials, there's making sure that we are tailor-making our potential new medicines to our local populations, who we know, genetically are very different from those in the rest of the world. Yeah, it's really tricky. In the context of this talk, I guess raising awareness is a really good place to start. So there've been some great publications on work that is being done at the moment, especially a lot of clinicians. We're lucky at a place like UCT to interact very closely with Groote Schuur Hospital, where we have an enormous clinical base. And we have a lot of clinicians who are commenting on this very matter. Let's amplify and promote the work that they've already done. It would be interesting to know your background, whether you're coming from a basic science perspective, thinking how can I make sure that my basic science work can translate into clinical practice. Maybe you are a clinician. Maybe you're just someone from you're a non-scientist who found this link online and have just joined and are asking from kind of the lay public's perspective. So even just in a question like that, it's important to be aware of all the different perspectives and ways people could be interpreting a statement like that. But of course, it's complicated. It's something we all acknowledge needs to happen, that we're working on. But when a major funder like the United States of America, particularly in HIV work in this part of the world, pauses or withdraws funding, it does make life a lot more difficult for a lot of us as scientists, but especially for those patients on the ground. Maybe we can turn that challenge into an opportunity as a way to really kind of reignite a passion for, as you say, improving and accelerating clinical research in Africa for Africans.
Fantastic reframe and way to look at the current situation. Are there any further? Oh, okay, there's one more question. We'll take one more. How does one communicate science with communities with low literacy levels, as is common in some African countries?
Yeah, that's very tricky. I mean, literacy, gosh, at what kind of level? Language literacy, different languages, scientific literacy. Once again, I guess knowing your aim and your audience. If it's school kids you're talking to in a different language, or a language that you're not confident speaking, and you're trying to get them excited about science, can you use graphics, animations, again, of which there are so many online that we could use potentially, with acknowledgement or borrow. Maybe there's scientific demonstrations, so something that is more sort of self-evident, that doesn't require speech or writing really to convey. If you're talking about scientific literacy, yeah, that's tricky, I guess. And also, again, are we talking at kind of school level or the general public? So I think just thinking very carefully about what message are you trying to get across? What are you trying to communicate? Are you trying to communicate the government's policy or stance on something? Are you trying to communicate why a treatment is not available because the US administration has paused all funding in that particular area? That's going to be very kind of emotive. Maybe you need to engage with community workers before you engage with the patients themselves. So again, I think you need a little more context, but just thinking about it is so important. And as long as you're not going in there thinking, I know the answer, I know the truth, oh, these people are stupid because they're not picking up what I'm saying, just that awareness and that empathy, we could all do with a little more of that, I think. So I hope that's a little helpful.
We're going to squeeze in one more question, a request to elaborate on your the examples of the scientists turned politicians. What is it about them that makes you feel that their scientific background contributed to their policies or politics? Were they advocates of science, or how did they advance the field? So tell us a little bit more about the Portland, Merkel examples.
Brilliant. Exactly. And thanks for the question. I mean, I think if someone hasn't done it already, there's a very exciting presentation or study or report waiting to be compiled, because admittedly, you know, in the cases of those three sort of celebrities that I mentioned, I really just went from their Wikipedia articles, which of course didn't then delve too much into their personal motivations. So whether those personal motivations were, you know, they felt they'd made their impact in science, but they now wanted a much to be able to make a much more tangible impact on society. Maybe they felt their skills, the problem solving, the holistic analytical approach that they learned as scientists could now be better applied in government. Maybe they were just frustrated and thought, well, I've had enough. I want to make the difference. I want to be the, you know, the change I want to see. So I'm afraid I don't know those answers myself, but I'm sure that there must have been sort of touched on in interviews, so we can really get sort of from the horse's mouth, so to speak, why. But otherwise, I think it is interesting to speculate, and maybe it's a question to ask yourself as well. Do you see yourself as a scientist for the rest of your life? I think once a scientist, always a scientist, right? Once we've had that training, you can't like become someone else or take off your scientific hat. But maybe if more of us were to follow unconventional scientific paths or unconventional career paths after having done that training in science, that many could benefit from that. And so maybe it's worth thinking about, okay, I want to be on the bench for the next few years. Then after that, I want to kind of, I don't know, maybe move into, if I can, a more senior scientific kind of manager sort of role. And then actually I want to pivot after that. I want to join like, you know, the SAMRC or somewhere, and really be at the forefront of making sure that the people who deserve the money actually get it. So I think these are important conversations for us to be having, and I really think we should bring it into the undergraduate level already when we have, you know, science career days, and even in lectures, to be like, you don't just have to be a PI. There are only very few professors and professorial positions and research positions in South Africa and on this continent. What are other ways in which you can, even if it's not still doing science, but using your scientific skill set to benefit society? Hope that helps a bit, Michael.
I think that's a beautiful note to end on. So as always, just to say a huge thank you to John. Thank you for your time, your passion, your expertise. I know it's incredibly beneficial to our network. Guys, I've included a link, all our links to the foundation and the H3D Foundation, and also John's links as well, so you can get in touch with him. And also there's an opportunity to give feedback. We always appreciate it. It's very helpful in thinking about new topics and new speakers and things like that. So if you can take a minute, feedback if you like. But other than that, wishing you a very beautiful day wherever you are in the world. And please tune in again. Our next one is in 3 weeks' time. And in fact, we've got 2 in 1 week. So clear your schedules. Okay. Thank you so much, everybody. Bye.
Thanks, team. Bye.